third day of our conference. The session chairman for this technical session will be Shri B.S. Govind. It's my honor to introduce Mr. Govind, who I think needs no introduction. He's well known in the foundry fraternity, and he has been previously on the board of directors of Kirloskar Ferris. Mr. Govind is a graduate in mechanical engineering and has also done his ME in Foundry Science and Engineering at the Indian Institute of Science. He has a MS in Production Engineering and Management from the UK. So worked as General Manager Operations at Mysore Kirloskar Limited. He is also an independent director at Kirloskar Ferris. Presently working as Technical and Management Advisor. And Mr. Govind has also been bestowed with the honor as a fellow member of IIF and is actively involved in the IIF activities. I would request Kshitij to please escort Mr. Govind to the dais.
Thank you. I would like to invite the first speakers of the day is Mr. Balaji Loganathan and Mr. P.A. Jayaraman onto the stage, please. I'll just introduce them. The topic of the day is how artificial intelligence and computer vision can help foundry achieve better productivity and safety and quality. Mr. Loganathan has over 20 years of experience in IT field. Surveillance, AI, software development for industrial applications. And Mr. Jayaraman is a science graduate and diploma in metallurgy, advisor on operational improvements and business development. Last worked with India Pistons as senior general manager, presently working as a consultant. Therefore, I would like to leave the stage for them now for presenting their particular topic on how artificial intelligence and computer vision can help foundry achieve better productivity, safety, and quality. Thank you.
Good morning, everyone. We would like to thank the technical committee of IFC and the organizing committee of IFC for giving us this opportunity to present how artificial intelligence and computer vision can help foundries to achieve max productivity, safety, and quality. My name is Balaji, and Mr. Jayaraman sir is a veteran foundryman. So we together are happy to present on this occasion. The agenda of the discussion today is to give an introduction and then how AI solutions can be useful for manufacturing industries and what we have done for the foundries and key areas that can be monitored in the foundries. An example with how the furnace life cycle can be monitored using advanced AI, and few case studies whose name we will not be able to mention, but we will show you sample videos of how we have done, and finally we will end up listing the benefits of AI in increasing operational performance. This is not a usual Adobe reader, so I'm finding some challenge moving from one presentation to another presentation. What we basically do is we take the existing CCTV cameras that are by law should be in a factory, and we convert that CCTV camera inputs into a smart camera. And how we do that is we use artificial intelligence, machine learning, computer vision, video analytics, and so on. So all we need here is just a normal camera that would exist in a factory. Even in this room may be having a camera, CCTV camera. That camera is enough to analyze the factory operation. And our software is a plug and play that can be used to read the feed from CCTV. And with that, we will be able to track and detect 4M, that is man, machine, method, and material, optimizes the OEE, and provide various analytics. And the most important thing here is it's not a post-mortem. The AI is not used for post-mortem in any industry, but it is mainly used to take a real-time proactive action. So that's the key thing here, because factories cannot afford post-mortem, and there are already a way to do post-mortem, but here is a real time. Less than 1 second, we will be able to tell what went wrong and move on with that. We are targeting AI can be used to address certain specific pain points that exist in the industry. With that, whether we like it or not, AI is going to come to the manufacturing industry in a good sense. It is up to us to make use of AI in a good sense, because we all know how AI is impacting human. So from day one, we have taken a motto that we will use AI for good, and most importantly, we will not use AI to replace humans. Already automations and robots are coming and replacing humans, but our intention here is to enable human to be a better human, so that a quick, faster decision can be made, with which we can give a positive impact by improving the OEE, achieving 100% OK, SOP compliance, analyze various trends that are going on in a factory, minimize the interruption, handle asset tracking, and so on. So these are all so many benefits that we can achieve by enabling computer vision in a factory. So I would like Mr. Jayaraman sir to take over.
So the furnace cycle monitoring using AI actually. The furnace process, camera tracks all the activities that is being done in the furnace platform, right from whether the human is having the safety equipments, charging, and then melting, and then pouring. Every activities is taken and it is monitored. And you get all the details on your computer screen actually. So cycle time between one charge and the other charge. The benefit what we get from this is the metal output from the furnace is increased. When the metal output increases, the power consumption will come down. Nearly 25% of variable cost in a foundry is power. It's a good potential for saving the power. So as a hardcore foundryman, I advise foundries to go for melting area where potential for return on investment is very fast, and once you have a track on that, it will be continuous. So apart from melting, other areas are there, but first to start with melting. So each and every cycle is monitored, and end of the shift what we do is we just call the furnace operator, melting engineer and HOD. They sit together, what are the gap has happened, how to close the gap in the next shift, so that the next shift moves forward with some better performance. So end of some 1 week or so, you'll achieve what OE you need for better performance.
So we have taken 4 case studies in that we will be showing you 3 case studies respecting the time. The first one will be furnace energy monitoring system, and then how we can measure the molding process with the DISA or COYO or such solution. And then the third one will be machine shop CNC solution.
This video is from one of the leading foundry. So it is observing the activities that is being done in the melting platform. So to start with, whether operators is wearing the PPE, and now is going to take the lab sample, and each and every activity is being taken, and time taken for that activities also it is caught actually. So each and every process right from the charging till the pouring and tapping, it is being tracked. And you see the time taken for charging, melting, everything computer comes on our computer screen. Now he's taking the slag out. Now what's the time taken for the slag? That is also comes, it's measured and it is displayed in the computer screen. So by doing this, the overall equipment efficiency of the furnace goes improving day after day. So you got the charging time and the melting time and the tapping time. So one time taken from one cycle to next cycle, that is given, and the OE also it is measured. Now tapping is done, that also now it will give a green once it is, yeah, it is. So by monitoring this melting cycle, what the foundry can get benefit is ensure that efficiency of the furnace is at least 100%, resulting in metal output, increase in metal output. When the metal output is increased, naturally power consumption comes down. The potential for power consumption is very huge in this area. So melting is the best place where a foundryman can get return on investment fast. And once he continues to follow that, it will be very good saving for the company. This video is taken again in one of the famous foundry in India, where the molding process is monitored, whether the mold quality is okay, whether it's placing the core properly, whether it's placing the filter core, whether it's placing the chapel. All the activities being monitored step by step and in seconds, so that any deviation, it gives a signal. Oh, you are doing some error, please stop it. It is not post-mortem. In the process stage itself, it is captured. So that you control the rejection in the process stage itself instead of getting rejected after shakeout. So this is one of the best tool to control rejections. And also the molding cycle, OE of the molding machine, how the 4M is played a role in improving the OE of the machine. Everything is tracked, and it's very good benefits for the foundry people.
So the last case study is how AI can be used in machine shop CNC based areas or lines. Yes, sir, I will tell you. And with which we can monitor the machine shop operation, whether the man is available or not, and so on. So we will show you a video of how we have done it for a factory in India. So this is a person is doing a very sensitive operation where it is important he have to wear the goggle, and if he is not wearing the goggle, then the camera will connect to the PLC system and automatically turn off the CNC machine or a relevant machine with the help of SCADA or PLC communication. That way the person won't even be able to do the job. This way he is also protected, because here it's not only about productivity, but safety is important. Apart from checking what is whether a person is wearing the goggle or not, we are also checking the SOP tracker. I hope you can see in this area where the mouse is being pointed. So the particular person have to follow 5 steps, a POKE or SOP, and if he miss one of the step, then we detect and immediately give an audio alarm or siren based on your needs. Because sometimes an annoying audio alarm will be good, sometimes a pleasant audio message would be good. In this case, we are giving a pleasant audio message. The other thing we are doing here is, apart from this live dashboard, we also give a complete dashboard of how long the cycle time and step by step time taken for a certain process to complete and so on. So this dashboard or this application can be integrated to your ERP or internal SAP system and can also be added to your existing analytics. So one important thing we have done is, as you know, the moment we see camera, we try to be a good person because the camera is watching. So that is nice in your public life. But when it comes to factory, the moment we place a camera, then the people will start feeling like someone is watching me and so on. So what we have started implementing is an employee rewards program. If a particular person wear the goggle and do his job correctly for the entire day, then he will receive a credit point. And once he start collecting the credit point, he can start having lunch with the plant manager or have a simple candy or something that respect his day-to-day activity. So this way, the good people will be more good and the non-good people will also try to learn from others and be good. So we are working on removing the threat that people or the factory employees may feel that a camera is watching me.
Of manufacturing in manufacturing industry, the safety of the men and the equipment is safeguarded. That is very critical for any manufacturing. And our return on investment is very visible, and you can get the return on investment. In melting area, many foundries have got within 6 months of time by saving on power and liquid metal output. And operator PP complaint, which is in melting area and other areas, many people not giving importance to safety, but this system ensures that everybody has the safety equipment which is need of the hour. An increase in metal output, reduction in power consumption, decrease in spillage. But in one of the foundries, we saw a lot of spillage throughout the foundry. When we saw open treatment for ductile iron and pouring metal, and this made awareness that metal should be spillage to be controlled, so that save on power by melting again the spillage metal. And reduction in quality rejection, that when in a desub machine we saw that any error in placing the chaplet or core, that is in the process stages it is captured, so that you need not reject the casting after knockout and all. In the process itself it gives an alarm, hey, you are not using the proper chaplet, correct it. So he immediately corrects it and you get a good mold out of it. And plan stoppages and by monitoring in 480 minutes how many minutes machine has worked, how many minutes it has not worked, why it is due to main machine, everything in dashboard, no manual entry at all. So that end of the shift, the team has to sit and see what are the gaps and what is the action needed, whether you need the management support or it is due to any action, and accountability, responsibility and the time frame is very critical. So you should work as a team and total employee involvement is very important, and training for the people is very important. And I have achieved this in one of my career, that when we involve the people, nothing works like that actually. Only machine can support you, but ultimately the men has to work. And another thing is in manual, in one of the foundries, they were checking the temperature. Out of 5 readings, the operator was checking only 3 readings. 2 readings he had not checked. You put some figure. So that can be caught with this actually. He ensures that temperature is recorded and the temperature comes into your computer screen. And manual process and reduction energy consumption maximum OE very critical. In one of the foundries I went actually, what is your OE asked? He said 60. I asked him to show the record. I said, no, sir, we are not having any. Then why you said 60? Accept the mistake, then we'll see how to move forward. From 60, that OE has input to 72. Just by, for example, manual charging has been replaced with vibratory charging, and time taken for lab check that has been reduced. By doing various measures, you ensure that melting time comes down, metal output increase, which results in reduction in power consumption. And reduction in breakdown and stoppage by planned and predictive maintenance and all, that can be monitored and ensures that ultimately the system will work, not the men. When the system works, the other top people can concentrate on marketing and doing further developments. So AI ensures that system works in the manufacturing company. Productive pattern analysis, reduce time wastage. Wastage, again, I told you spillage in machine shop, coolant leakages, oil leakages. In one of the foundry, an auto pour, and while pouring, lot of pipes and air connections. So metal just fall onto that, and pipe got burst. So this one, when there is any metal coming up through the parting line, so that auto pourman stops the pour. So by doing all these things, we control process, improve the profits of the company in the present scenario where the raw materials are going. And yesterday in meeting, one of the from Cummins, that you have to improve our operations. They will 100% fetch you the better results where you can improve your profits by controlling the process. Those are the advantages.
Came to the conclusion of our presentation. Our main goal here is no more products recall. So you might hear a lot of stories like sometimes Hyundai would recall a car for certain reasons, for safety reasons. Volkswagen recently lost billions of dollars while recalling. So we want to address at the grassroots level, at the source itself, and that's our motto. No more product recall, but let's achieve it together. And thank you, slide.
Thank you, sir.
I throw open the forum for questions, please.
Take my.
Hello, check.
With the more sound and clarity, I would like to start. I am TV Nagaraju, representing Sanmar Matrix Metals Limited, Viral Malai, central part of Tamil Nadu. The presentation in your system is really seem to be good, and we appreciate the efforts taken to put forward all the benefits to all the foundrymen. We are having a steel foundry. By having the experience of the foundries for the last 30 years, I've got 3 questions for both of you. Number 1, in foundry, everybody knows that it is a smoky and dusty atmosphere. Even though some of the foundries are coming up very clean and tidy, but most of the foundries are still going under that particular type of atmosphere with the what called knockout, sand, dust, and heat. So how your cameras are going to have clarity and capture of the data in all the climatic conditions of the foundry, and basically all the foundries are working for 3 shifts, how it is going to effectively work in night shift. So this is the first question. And the second question, you have shown that one single furnace is being operated and the camera is capturing the data. What happens to a melting platform where we have multiple crucibles? Is it going to be having different cameras, or a single camera is going to capture? How are you going to differentiate from furnace to furnace? And the third thing is that whatever the benefits we are going to get out of it is the real-time data capture. How are you going to transfer this data to the company's server, or are you proposing to have a separate cloud area where this data is going to be stored? where everybody will be really concerned about the data security. So I wanted all three to be addressed by both of you. Thank you.
Camera did that dusty atmosphere and illumination issue. We had a similar problem in one of the foundries. What we advised is put an enclosure for the camera. Even that smart spectra was totally dusty actually. So we advised them to put an enclosure so that no dust comes inside. That is the one thing. And we asked them to improve the lighting. In the day itself, it was so dark. Then we advised them to go for the transparent sheet, increase the transparent sheet so that the daylight gets improved. And in the night shift, provided you take care of all this, in enclosure for that camera and improving your lighting. And now the system is going on very smoothly there in one of the foundries in South India. And coming to the second point, I think what he said is camera.
From the very beginning itself, we go with multiple cameras. One computer or a GPU machine can handle up to 10 cameras. So the maximum we have used was 8 cameras that will address the factory from start to end. So we capture multiple cameras but still give aggregated data on your dashboard so that the person won't have to switch between the cameras and see that. So practically we have achieved it in one of a big manufacturing plant in Pondicherry. And everywhere we go, we don't go with a single camera solution because the end-to-end have to be addressed. So we always go with the multiple camera solution. So it is feasible, sir.
Coming to your point that in melting area where you have 8 furnaces and all, we need at least 3 cameras to get the proper, one camera is not enough actually. In one of the foundries, we place 4 cameras also to take 8, to read the 8 furnaces. So in melting furnace where you have 8 furnaces, I think we need 3 cameras to get the proper data, correct data.
Okay.
Sir, to your last question, sorry sir.
Yeah. Continue.
To your last question where you have to use our system, that is not our intention. Our intention is to start integrating with your existing solutions, applications that we have with APIs. So we have been into software for the last 15 years. So we have integrated with discrete systems. So our experience make sure that you see the data on your existing system so that you don't need to depend on us. The most important question is where this application is going to run, because factories have their own privacy and sometimes we may not be able to achieve the compliance that all the time. So we offer on-premise solution, and if factory requests that I have a secured cloud, I would like to place it on a secured cloud, we do that as well. But we recommend on-premise because we are on-the-spot solution provider than a cloud data transfer and all will take more than 1 second. We want to address the problem within that 1 second. So we offer both solutions.
Okay, thank you.
Any other questions?
Please give the mic.
Hello. You explained the visual abnormalities identified through AI model, but you have done any work with respect to process parameter abnormalities through AI model?
Of course, yes, sir, we have done, sir. I told you, in Disamatic, when there is processes going on, any error in placing the core or filter core, anything that gives whether you want in a signal or you want the WASP message or want the machine to stop. Okay. It asks you, whichever you prefer it gets. Suppose in one of the foundries, instead of 4 mm chaplet, they place 6 mm chaplet. Okay. Immediately, hey, you are not doing the correct job, place the 6 mm, it gives an audio. So that you place the correct chaplet, so that you avoid rejection at the latest. Okay. And similarly, you saw that SOP monitoring, one of the companies, whether he is doing the SOP as per the standard operation procedure. Any deviation, immediately it gives an alarm and gives a signal so that he corrects itself, so that he goes for the better processing. So everything it is online, sir. It is process. It is no post, as I said, it is no post-mortem. So by doing this, you are correcting the process, you ensure that rejection is controlled. That is the AA specialty, actually, I can say.
Okay, coming to the chaplet, that also it will identify through the visual.
Only thing is the camera, that camera that needed actually. For melting and all, one type of camera. For to observe very minute, we have to go for a next step actually, but it will observe. In one of the foundries, you have done,
Okay,
but especially chaplet.
okay.
Yeah.
No, that is also comes under visual, this one, abnormality, sir. My
Yeah.
question is specific to, for example, if you are pouring at 1400 temperature, or if you're the kind of range, if you're keeping for temperature, pouring temperature range or pouring time, that kind of abnormalities you can able to identify through the
Yes, sir.
AI model as of
With
you have done any
pyrometer
work
reading,
in that area?
pyrometer reading, it is connected to your computer. So what are the readings? It just transferred to your computer screen actually.
Immediately it will show any, this one, silent to the.
Yes, we also read multiple parameters by integrating with your existing products that you will be having, where you read temperature, pyrometer data, spectrometry data, and so on. So we read those data and make sure that it is at the right temperature, consumed within the right time, and so on. So it's an integrated solution.
Okay. And what about the data captured thing through all the cameras? What about the size of the all the data captured and how long you can keep it this data for?
So we store only the abnormalities. We
Okay.
don't store the good things. We record the good things as data. Only the abnormalities clips are stored, which will be like 10 seconds to 1 minute. It will be sent to the plant manager or any escalation mechanism that you have. So the amount stored is less.
Thank you. Due to the time, this thing, I think I'll have to ask one or two questions myself and then do that. First point is, I would like to say that automation, we don't remove people, even in the machine shops. Because automation is more for quality improvement rather than removing people. Therefore, we look at quality improvements. Therefore, I don't think anybody is looking out for automation to reduce number of people. Therefore, I would like to correct that particular statement that you made. Then, particularly we have to show the case study of furnace. In the furnace case study, the major advantage of this AI would be on monitoring whether the furnace has taken full power, because that data is the most crucial data, and then you can analyze this thing as to why it has not wasted time or why the furnace did not take full power, and then take the corrective actions so that you improve the productivity and reduce the power consumption. For AI helps in that way when you are monitoring and then getting the data on your screen immediately in a real-time basis. Then, in the molding, as you rightly said, that you have to have some special cameras to identify where the person has gone, does a mistake, so that you can prevent a problem. Therefore, it will call for certain investments, but it is worth it to see that your rejections comes down. And one important thing that was talked about in the machine shop is the safety. Therefore, that is a real good tool. Now, today, you have got even helmets and other things with goggles and everything with AI display of your SOP or process or whatever it is. There is a lot of advancement going on in AI, and then slowly it will all catch up in India also. Therefore, this is a very good start that this company, the team has been making. I'm very good. I'm very glad about that. And then I know the question will be, there will be some postmortem, because we have to analyze what is there, because nobody can be watching all the your cameras all the time. Nobody will be doing that. But at the end of the shift, as you rightly said, the people will sit down to find out where the deviations which has been recorded, and then discuss and then see how to improve. Therefore, AI as such is a new thing that is coming in, and the industry, particularly the major bigger industries, will have to catch up with that, and then they have to implement it. Thank you very much for your presentation.
1 minute. And Mr. Govind told the manpower reduction. He did in melting actually. What he said is reducing manpower is not our, but there is something also. For example, instead of manual charging, you can put for auto feeder, where you save on manpower. In one of the company, 4 people are charging one steel bundle each and every time. The auto feeder just like that, within 2 minutes is charging. It takes 10 minutes, it takes 2 minutes. So savings in manpower is also there, and by auto feeder you are reducing the charging time, and which is the metal output. And Mr. Govind also told that end of the shift you sit, the team has to sit, analyze the gap, accountability, responsibility, time frame. These are all is a must. Then only it will work. It's totally a teamwork, and with teamwork and total employee, everything can be achieved.
Thank you. Thank you for your presentation. We would like to give a memento for this.
Thank you. Thank you. Thank you.
I would like to invite Mr. Santosh
Thanks,
Kumar
Nagarajan.
onto the stage, please. Mr. Santosh Kumar is a tool design engineer with 13 years of experience in usage of computer simulation. And I welcome him to make the presentation on prediction on effect of resin bonded percentage on casting quality using casting simulation software. Thank you.
Good morning, everyone. Myself Santosh, and I'm representing ProSim R&D Bangalore. Thank you for the opportunity for IFEX to give this presentation and working with foundry region. Today we are here to discuss about how the resin and kind of binders we are using in your foundry, how we can do the optimization, utilization of the in your cores and sand molds, and how it is going to affect on the quality. We are going to discuss through the simulation. We can analyze and we can use the optimum percentage, so that how it is going to affect on the quality. So just to give the introduction about the topic, we are going to use the inside core to get the internal shape of the casting. So for produce the cores, we are going to use the binders, resins, and all to get the good strength and also high pressures inside the cavity during filling and solidification. So that to get the good strength and the good core properties, so we are going to use the good amount of resins to provide the negative provide the negative effect of the binders to produce the core gases come out with the molten metal. So when the molten metal it's pouring, whichever the during the pouring, the molten metal, it is going to react with your binder chemicals. So because of that, whatever the gases it is going to create, there we have to give a passage. Otherwise, it is going to inert into your casting. So because of that, you are going to end up with a pinhole defects or blowhole defects or gas porosity defects. So in order to understand this, what is the root cause of this defects and what is the amount of binders or percentage of you have to use to get out this of casting. To come to that, how we can use, the thing is effect of the quality of the casting, we have to give the sufficient venting to escape the mold gases through the cores and also to get the sound casting, either in the inside the core or out in the either through the in the gating system, the air vents or metal vents to escape this air. So that in order to predict this, we are having a system. So what is the kind of percentage you are using as a binder with respect to that, with respect to temperature versus time. So the gases it is going to evaluate once it is touches your molten metal touches your binder and your core and sand mold. So we are going to understand here what is the benefit, so that you can understand by doing this through the simulation is we can understand the overall the end of your casting, if you are finding that the defective castings, so that your process is going to be in a completely it's going to waste, or you have to do the remelting. So instead of doing that, you can cross verify before you are producing your core or your castings, so that you can reduce your raw material and reduction of time and development and operational cost also. Obviously, through this, we have already come up with so many long year utilization of casting simulation in a foundry to improve the yield, quality of the part, rejection rate, and turnaround time also, lead time and all. So this is new aspect coming into the cores and binders. So you can use different types of cores you are using in your foundry. We can apply this. Either it's with respect to hot box cores, or cold box process, or hand rammed cores, or like that. So you can utilize for any different types of cores this system, and you can understand what is the end results you are going to get through this system, and you can understand the quality of the casting also, and how much the gases it is going out of the coming out of the core, and how much the passage or your permeability it is available in your core and sand mold, either it is sufficient to escape that air or it is going to inert into your casting quality, so that it is going to finally it is going to cost the quality of the product and also the cost of your process. So that here we can understand with oil bonded cores also and resin bonded cores also, shell core and sodium silicate cores also. Moving further, we are having three different types of core process. In this hot box core process, we are going to heat the box, and with the heated the core boxes, and it is going to made either with cast iron or steel or aluminum kind of your core boxes, and it is around 350 to 500 Fahrenheit. So we will get the shell cores or hot box core process, and cold box core process also, as you know that the similar way. So we are going to use with the different cores. So we are going to use the different kind of binders and resin, different types of cores, oil bonded cores or resin bonded cores and shell cores, sodium silicate cores, like that. We are going to use the different binders and different kind of process making the cores. So these are all the different types of cores we are using in our day-to-day our mold and mold in our core area. So what are all the if you are using different either organic binders or inorganic binder, we are going to use different kind of chemicals, and it is going to generate different type of gases during the process. So we can understand from either through the organic binders, there are different kind of binders we are used, and it is going to come out with different gases in this using organic binders. Similar way, inorganic binders also. So here we can understand either if you are using inorganic or organic binders, how much the gas evaluation rate it is coming out during your the molding process from the core, and how it is going out of your through your core and also casting and also the mold and to the atmosphere. So this is these are all the different process using a binder. You can either hot box and cold box cores or shell cores. So coming into this is the core gas defects, how we can identify. This is the overall things. Once the molten metal it is filling, during a filling, it is going to contact with your sand core, and also it is going to, once molten metal touches the sand core up to 200 degrees Celsius, there is not much gases it is going to come. After based on your ignition temperature or chemicals you are using, based on the temperature, from that particular point, the core gas it is going to come out. So we have to provide a system to escape that gases through the core and also through the permeability of your core and mold. So here what is going to happen, the molten metal it is started pouring into a cavity, and during a solidification it is going to react with the molten metal with your binders. So it is going to escape we have to provide a proper venting system, either core venting or metal or air venting in the gating system to escape this in order to avoid this core gas defect. So, and also coming to what is the root causes of the defects with respect to different process, either pouring process or molding process or design and melting like that. So in the design area, if you are not providing sufficient venting, it causes the core gas defects. Coming to the molding process, if you are not having the proper optimum percentage of binder, it leads to your core gas defects. Like that, we are having other areas of identify the root causes of the defect in different areas. And also it causes the permeability of your sand, how much the permeability your sand, core sand, and also your mold sand you are using. Okay, moving further, here this is one of the case study we have taken to explain how it is going to work and how you can understand through the simulation. So here we have taken two different kind of binders and the percentage. In this you can understand how the core gas it is going to generation rate, and how it is going to influence on the quality of the casting. Okay, so here to produce the cores, we are going to get the good quality of the casting and also good core. It's required a high strength of the core and different binders we are going to use in this. So here this is the two case studies we have taken. One is with resin coated core, and another one is with furan process. This is the gas evaluation rate with respect to temperature in both different cases. Here in the first case, up to the 200 degrees Celsius, there is no gas, or we can say less gas. It is going to come out from the casting during the process. In the second case, the ignition temperature of the second case is after 400 degree. Once it touches the 400 degree, the core gas evaluation it will take place. So here we are going to compare with two cases with respect to percentage of binder you are using, and also how the gas evaluation rate in your core and also throughout the process. Okay, and we have taken, this is the case of cast iron case study. We have considered all the similar how we are doing with your process, same, all the mold material, casting material, and pouring temperature, fill time, everything is same. And this is the green sand molding process. And moving further, here you can understand what are the kind of results you can understand through the core gas analysis. We can understand how much the mold gas pressure we are getting through the core, and also how it is going out also. And the gas generation rate we can get as an output, and also core gas velocity along with a vector and magnitude, means the direction, and also what is the amount of core gas it is coming out of the casting through the core, and it is going to the mold and to the atmosphere. So these are all the main 4 output results you are going to get from the core gas analysis. Okay. Moving further, here you can understand this is the gas pressure it is going to evaluate. Here this is the resin coated sand, the left side one, and the right side one is the furan hot box core process. We can understand by seeing the color and also the number here, the resin coated sand is initially it is started the core gas evaluation at the 200 degree temperature, and it is in both the cases it is happening, the core gas it is hitting in the center, and coming to the high gases in the furanic this one, and resin sanded is lesser, and it is in the center area. In this center area, there is a chance of getting, in this 2 particular areas, chances of getting a core gas defect. So we have to provide in the center core and also the gating system sufficient amount of venting, either through the drilling a hole in the core and also in the gating system to evacuate this core gas during the solidification to escape from the inside your core and also to the mold and atmosphere. So we are getting in this compare with resin coated sand and the furan sand, we are getting the gas pressure in the resin coated sand is less, and also the furan hot box core compared to the furan sand coated and resin sand coated sand. Okay, sand mold. And moving further here, this is the gas generation rate in this. Here you can understand this. In the resin coated sand, we are getting less at the blue color, and the red color indicates that which are the areas it is going out the sand and it is getting inside into the your casting. So in this area, there is a chances of getting the core gas generation into your casting. If you are in that particular area, it is getting inside into your casting. So this is with respect to gas generation rate. And coming to the velocity and this vectors, here you can understand that this velocity vector shows that how the gas it is going out of your core and which direction, how much the amount of core gas it is going out of your the core and through the and also it will consider the your mold and core permeability also. So that here you can understand in this area, initially it is started from the center, it is going towards the end, and after some time it is going to concentrate in this particular two regions. So there is no provision if you are not provide the provision to escape this core, the core gases. So it is going to inert into your casting. So it will going to create a pinhole and blowhole and gas porosity issues in your casting. So that we can understand without core or without core venting or getting venting, so how it is going to react, and after providing venting, so in the core or getting system, how we can eliminate this defects during your process before producing your casting, so that you can concentrate on the producing good quality castings, and also you can eliminate this core gas related defects using this core gas analysis simulation. Okay, and coming to the conclusion, in the single slide you can understand all the four results, and you can understand in this video, and this is the core gas solid fraction also. You can understand how the solidification it is going to take place in your casting. At the similar time, how much the gas pressure it is generating, and how much the gas velocity vectors it is, in which direction your core gases it is going, and the gas generation rate, so that we can understand from concluding in a single window, so that we can come to the decision making that either it is going to create any core gas related defects in your casting, or we are not getting any core gas related defects. If you are not provided sufficient venting, so that you can understand where you will get a core gas defect, and you can give that the sufficient venting with respect to by seeing how much the gas generation rate and the volume, so that you can provide the sufficient venting area to escape these gases out of your core, and also through the mold also. So that all these things it's going to affect on your end of your casting quality, and also the process and the utilization of all your resources in right direction. And this is the overall conclusion. So compare with two case studies, we are getting the less gas generation in the resin coated sand compared to the furan sand. The thing is because of the more core gas generation in the case study we have observed. And similar way, this is not, I'm not telling in generic way, it depends on how much the percentage of binder you are using. Based on that we can conclude, irrespective of if you are having different binder percentage or like that, we can understand which optimum binder percentage it is going to give the good results. We are not saying not use any kind of binders. You can use any different kind of binders or cores, but you have to understand how it is going to affect on your end of your quality of the casting. So this is overall my conclusion. If you are having any questions, you can open to ask for the question related to the overall the case studies. We have done other cases also, because of we have signed with other parties, all the NDA and all. We are not able to explain with particular cases. We have done and we have got very good results in the high pressure molding system also, and other sand casting and all the iron and steel castings also in this. Thank you, everyone. If you have any questions, I'm open for happy to answer your questions.
Any questions, please? Now, I will ask the question because nobody else is asking. Okay. You see, the question is the gas generation depends upon not only the particular type of binder that has been used and the quantity of binder that has been used, but also depends upon the particular temperature of the metal, of the pouring of the metal, or the type of metal that is being poured. Second question will be, the second problem will be, what is the thickness of the metal around the core? Therefore, certain areas the thickness may be low, certain areas, how much heat is being taken by the core and how much of burning occurs. Suppose if you take a bigger core like a machine tool casting, where the thickness, the core size is about 2 feet or 1.5 feet thick, only the end border only about 1 inch thick only gets burnt. Rest of the things will not get burnt at all. Therefore, the question will be, how your software is able to recognize that and tell us? Or is it that we have to do some preliminary work to find out what is the type of gas generation, how much is going to come and all that, and then feed the data into the software to get the output? I am not able to understand that particular part of it.
Okay. Sir, coming to the first question, we are considering pouring temperature or other parameter. We are already considering as a boundary condition and in the simulations as an input to the system. So we can consider the either pouring temperature or other process parameter also. The pouring temperature, pouring time, and other aspect, mold temperature, core temperature also, and the core and mold properties also. Coming to the second question, the core gas evaluation rate, you can use the standard data, or if you are having in-house the facility, how much the core gas generation with respect to your percentage of binder you are using, we can feed this data to the system also. We have the both standard data also, it is available with us. If you wanted to customize your own practice, and we can do the customization also. And coming to the third point, we can consider either how much your heat transfer in the core as well as in the mold. We can track that, and we can measure that till how much depth the heat is transferred from your in the core area and also in the mold area, so that we can understand how much the heat transfer rate. So that by to understand the heat transfer rate, we are considering conduction, convection, radiation, all the heat transfer modules, and we have all the heat transfer rate in the standard wise also, with respect to the boundary conditions.
Therefore, does it tell you that once you make a simulation with a particular size of vent, therefore the casting defects can be eliminated to say that there won't be any problem of any blowhole and all that, and the evacuation area is quite sufficient, and then there won't be a problem? Is it that the way to use this particular software?
We can understand through the simulation using a velocity vector and gas generation, different output results, how the gases it is going out of your casting. If there is any abnormalities, it shows that it is getting insert in the gases it is inert into your casting. It shows along with a magnitude and also the direction of your gases, in which direction it is going. So that we have to read. Software it's a tool to understand how it is the end result. So we need to understand as a design engineer or a process owner, we need to understand the results in the right way, and we need to optimize our process. Software, it will not give the end solution. We have to understand the results, and we need to communicate in a right way.
See, one thing is when the title of your paper, when you say that the effect of resin bonded percentage, you see, the percentage of the resin or the material binder that we use will depend upon the properties that we want. Therefore, what is the strength of the core at the first hour? What is the strength after 4 hours? What is the strength after 24 hours and all that? Therefore, that percentage we can't change and then try to find out I will reduce the percentage and reduce my gas defect. Therefore, I have to put that percentage of resin to get my properties for the core to withstand the metal temperature, metal pressure and all that. The question will be, that how it will indicate when you have a certain percentage, what is it coming, and then how you must evacuate the gas rather than try to control the resin percentage on costing quality. I feel that there should be a little change in the title of the paper.
Okay.
Any other questions from anybody?
Yeah, I am Biju from the same foundry, that's Sanmar Matrix Metals. So here my question is, the gas is not only generating from the core, it is coming from the mold, it is coming from the pouring temperature,
Yes.
or it is coming through the flow itself. All those things are the reason for gas.
Yes.
Yeah, so here only from the core, if you are going to address, then how you are going to address all other parameters. Also, when we are doing a simulation, we may be using magma simulation or some other simulations. So whether this is linked with this simulation and we will be able to get the gas rate. Because this, my belief is that only gas solution is not the reason alone for the gases on the metal. And
I understand, sir. I understood your question.
Yeah,
So it is not only depend on the core you are using. We can understand in the similar fashion your molds also, cope and drag also, and we can understand through the your pouring temperature or molten metal you are pouring. From that also we can understand the gas generation rate also. So that this is one of the example I just explained with respect to the core. Similar way we can work on the molds also. Either irrespective of your molding system, we can understand, we are considering all the mold properties, all the density, thermal conductivity, and also permeability of your mold, different molds you are using. So that also we can consider, and we can understand the mold gas generation rate also. Means we can understand through that the same module your cope and drag generation rate also. How it is going to affect on your quality of the casting also.
Yeah, how it is connected with the simulations for the general solidification simulation and this one?
The flow and solidification is a process. During after immediate flow, during the molten metal touches your core binders and all, the gases it is going to evaluate. It is going to start the gases evaluation. During the solidification, it is started coming out. If the solidification is already completed in that particular area, still the core gas the gases it is generating in your either mold area or the core area, there is no provision to escape. So in that area, it is going to create a problem of your core gas defects.
And how they connected with the material, because different materials, different reaction will be there to the mold. So
we are considering the materials in the either casting or mold materials in the as a boundary conditions.
Okay.
I would like to say one thing about this simulation. See, initially, simulation was mainly for...
Hello. So
Yes, sir, yeah.
So my question is, do your software only cover up the gas defect, or it also can indicate the shrinkage in the casting?
So shrinkage, all the flow related and solidification related we can identify, and this is the new thing we have come up with. So that is what I try to explain. I'm not saying that it is not possible, the flow or solidification related defects. We can check with all the shrinkage, gas porosity, and misrun, pinhole, blowholes, and cold lap, all kind of flow and solidification related defects.
So do your software somehow link with the Magna software?
No. That is also the similar kind of software.
No, up to now, whatever simulation we have been doing
Okay.
with some other software companies,
Okay.
so they have been giving us the report
Yes.
that whether shrinkage will come or not, and shrinkage will be appear in which area,
Okay.
which part of the casting.
Yes.
So from your presentation, I came to know that we can also focus on the gas defect which will be generated from cores.
Yes.
And,
Yes.
and for those cores, the basic parameter can be the binders.
Correct. Not only the binders, all the boundary conditions we can consider how you with respect to your process.
I'll interrupt here. You see, I was just trying to explain this. Initially, simulation came in for mainly to find out the hotspot and the shrinkage. It started, evolution of simulation started with that. Then the flow simulation was brought in, where the metal flow also was considered. And then how the gating system is working, and temperature, how the temperature is behaving inside the casting. Therefore, as you go on pouring metal into the mold, the temperature goes on dropping. For example, you might have started pouring at 1410, let us say an iron at 1410 or 1400. Now, I have found cases in certain castings, at a certain location, as the metal is filling, the temperature drop is up to even below 1200. Therefore, all these simulation packages gives you the data to say what is happening for the liquid metal, temperature, and how the metal is filling. And now the software is also now improved to say that from which gate, how much metal is coming, and where is it flowing. Therefore, different colors can be given to say that gate number 1, the metal is coming here, gate number 2, the metal is going. Like that, there is a huge evolution that has happened in the simulation packages. As the numbers are, version 1, version 2, version 3, version 4, there is always an improvement in the new versions. Similarly, what this person is saying is that in their particular software, they have introduced another module. The another module is for the core gas. Therefore, you have different modules. One is for solidification, and another is for metal, temperature, flow, and other thing. Now, there is another module for the core gas.
So this is the additional module.
These are all customized module. You can buy it or you don't have to buy it. It will not be given together. Therefore, everything costs money. Therefore, initially, the major simulation is, normally, now today, we use flow much more than solidification of shrinkage. Flow is becoming much more critical to look at, and then use the software to the extreme benefit. Therefore, the simulation really helps for not only removing the shrinkage properties and looking at properties, but also to avoid cold shut, cold lap, and a lot of other defects that can be coming in. Therefore, the question is, the simulation gives some outputs. We must know how to use that output. That is where the learning will come into play. I would always advise even a medium-sized foundries to go for simulations, so that your development time can be reduced and the first time can be achieved in most of the cases.
Thank you, sir. Thank you.
I thank Santosh for his presentation. On behalf of IAF, I would like to give you a memento.
Thank you, everyone. Thank you for IAF.
Now I would like to invite Mr. Dipak Kumar Ghosh onto the stage. Mr. Ghosh is a graduate in chemical engineering, a postgraduate in polymer technology. He has got over 40 years of experience in production and development of polymers for foundry binder applications. He has presented several papers in national and international conferences. And the subject of his talk today is on inorganic sand binder systems, no longer a choice but a compulsion. Therefore, I open the forum for him to talk. Thank you.
So my topic is transition from organic to inorganic binder systems. No longer it is an option, but compulsion. Why? I'll be very quick because time is left. Mr. Govind has given me only 15-20 minutes. So I'll try to finish as quickly as possible. And if in case there are some leftover, you can contact me, my email ID or telephone. Foundry industry India is second largest in the world and is a major contributor to the GDP of manufacturing sector, for which government of India is looking for growth from 15% to 25% in a decade. That is ambitious growth. At present, 5 lakh workforce are directly and 15 lakh are indirectly engaged in 4,500 foundries to produce nearly 11 million tons of casting per year. Incidentally, this industry is one of the most polluting industries in manufacturing sector. But looking for its importance, we cannot afford to close down this industry either. So let us have a quick look of evolution of sand binder systems in world market as well as in India. Cell process, a heat curable sand binder system, was introduced in world foundry in 1944, and that was the FR synthetic binder. It was invented by Dr. Johannes Kroning in Germany, which was officially presented in GIFA 1956. Next came carbon dioxide cure, sodium silicate. It made a revolution when it was introduced in 1950s. It was ever first synthetic binder which could be cured without the application of heat. Between late 1960s and 70s, liquid hardeners were introduced, for which sodium silicate could be cured with this liquid hardener. So it had two options, either you cure with liquid hardener or gas. After that, between 1960s and 70s, a lot of...
Mr. Ghosh, if you could go to inorganic binders right away, it will be nice. Otherwise, it will take more time.
Okay. So, so let us look into it why organic binders are no longer a choice. See, organic binders and foundry environment. Over a period of time, it was realized that organic binders cause pollution in foundry environment to varying extent. Among pollutants, chemical pollution caused by vapors and gases of organic sand binder systems at different stages of mold making, handling, pouring and post-pouring are major contributors to the pollution of environment. Like plastic bags in packaging industry and bottled drinking water in consumer industry, organic binders, once considered as a cosmic gift to metal casting industry, is struggling today to get alternate system which can offer your better environment and free from pollutants, many of which are lethal and pose health concern to varying extent, right from your depending upon concentration and duration of exposure. There are numerous publications on ill effects of various sand binder systems on human health and comparison of those between one another. Modern foundries with ergonomically designed soft floors with cross ventilation, shifting away pouring area from mold making area and likes have improved foundry environment to some extent by prohibiting accumulation of vapors and gases, but it is not enough. Being matter of health, there cannot be any compromise. Toxicity of emissions from different organic sand binder systems. Molding sand bonded with organic binders undergo pyrolysis at metal pouring temperature, releasing polycyclic aromatic hydrocarbons, benzopyrene, BTX. These compounds are particularly harmful due to their carcinogenic, mutagenic, and teratogenic effects. All these are dangerous. In numerous emission tests in which alpha set sand was introduced in India in around 1986, and then it took a jump in the application. It took share of many other organic binders because basically of it, your environment friendly, your behavior. So that I have shown that this your polycyclic aromatic hydrocarbons, BTX, from pyrolysis of sand binder system took place in case of alpha set also, but in much smaller quantities than other organic binders widely in these foundries. So out of the organic binders also, there is a classification. Different binders cause pollution to environment in different way. So alpha set is a better choice among many. So molding, then second, there is a study is done by Professor Holger and his team in Krakow, in Poland, in AGH University, which says molding sands with alpha set release low amount of substances from BTX. It is up to 25% lesser, and polycyclic aromatic hydrocarbons up to 50% lower than molding sand with FNB or furan. As such, furan is less polluting than amine cured cold box and PEF set, and alpha set is lesser than that. So quickly I will switch over to inorganic systems. So now there is a trade-off between economic output and environment protection. We need to produce castings. We also need to improve workplace your environment in foundries to protect mankind from exposure of toxic vapors and gases generated from organic binders at different stages. Air will blow, yet candle will glow. The scope for this presentation is to discuss about possible modifications in formulation of existing organic binder systems, as well as introduction of inorganic binder system. Inorganic binder system is the last say for environment and your pollution in this foundry, but it cannot be done altogether at once. So initially, or in phase, your first phase, along with the inorganic binders, if we can improve the composition of organic binders to reduce the your emissions, and then it will definitely improve the your environment. So these are the constituents of commonly used binders. I will not I'm not going to talk about this constituents of amine cured cold box and organic binders. I will talk about alpha set. Alpha set is also phenol formaldehyde resin, but is in water media, and it does not contain your polycyclic aromatic hydrocarbons, and free phenol and formaldehyde in alpha set is very, very less. Then I will come to another binder system which is close to your alpha set. It is CCP, or carbon dioxide cured phenolic. It may be used for making cores as partial replacement of amine cured cold box. This binder system is there in Indian market for about 2 decades, but it could not find much growth because of 2 factors. Number 1, productivity, and number 2, your difficulty in producing thin section coats like water jacket. And I am going to talk about another self set, which is functionally modified silicate, your inorganic binders. This is the self set version of silicate. Of course, it is modified. Unmodified silicate works at not lesser than 4.5%, but with good sand, this silicate system can work at your addition level of as low as 2.25% by weight of sand with liquid hardeners. Same way, your gassing version of the modified silicate can work at a lower addition level. Lower addition level means better collapsibility. So it is a trade-off between economic output and environment protection. So these are the properties expected from binder system. What are the properties expected? Number 1 are functional properties. You have to get a good bench life, to get time to fill the pattern. Then you have to have a strength to remove it from molds, which it can be 2 types. It is flushless and flux fluid. That means at that stage of steeping, you should have sufficient strength so that the mold comes out without deformation and breakdown. And then this is the strength required in the, which is called dry strength, and is applicable up to closing of the mold, and which we are very serious in each and every foundry. In sand control test, they check the strength. Of course, it is not simulating. It is 1 hour, 4 hour, 24 hours like this only, without looking into what is required at what stages. And then the most important part is, after closing, it comes into the contact of liquid metal, where it should withstand the pressure of the liquid metal at the high temperature for few seconds to minutes, depending upon the skin formation time, and getting a rigid shape. Then after that, it should be removed without much of your energy consumption. It should be removed easily, which is called decoring, which appears in post-pouring. So additional properties are environment, economy, productivity, and ease of reclamation. The objective of challenges to make foundry environment free from chemical pollutants. It cannot be done overnight. Like any other development, foundries have to come forward for conceptualization. Process has to be in phases. beginning with small foundries, many of which are already using sodium silicate. So this is the system I am going to talk about. It is just a simulation. Suppose I am telling that this modified silicate with liquid hardener, it will be working good as a binder, then I have to prove I should get the basic properties also. So for basic properties, we have taken your alpha set sand from a particular foundry where it is being, and the same recipe has been followed to make compression samples, and with the new binder systems also at a particular addition level we have made samples, and you can see that alpha set which is a proven binder which is with blue color, and the functionally modified silicate self set with the red color. Strength can be achieved more or less same, or you can improve again by making additional level little more. So it is possible to get the dry strength up to closing over this system, which is absolutely environment friendly, even more much more friendly than alpha set, which is safer at present time. So once the dry strength level is assured, then you look into the hot strength. Now, for the testing of hot strength, there is no model, there is no instrument available, at least in Indian market, which simulate. So I have tried a method for testing the hot strength, at least relatively, and I will show it in the next slide. And now this is the hot strength, means what happens after molds are made, you coat it. After coating, either you bake it or you apply thinner base coating and then cool it. So that is the base sample, or that is the datum for subsequent strength in hot condition which is coming to in contact with the metal. Hot and return strength starts for there only. So this is a model for testing hot strength of organic material, organic binders. So this is the alpha set. Again, it has been taken in a sand collected from a foundry which is practicing in the same recipe. And the model is like that. After coating and cooling, you put the samples in furnace at 550 degrees centigrade, and every 5 minutes bring out the sample and crush for compression strength at different 5 minutes interval. The blue lines you will see, it is in hot condition, and the same samples, the red line in cold condition. You see up to 10 minutes, cold strength is more than hot, and after 10 minutes, in 15 minutes, the sample has crumbled and your cold strength is lower than the hot one. So this can give an indication of the hot strength of a binder, and you compare from composition to composition, formulation to formulation, or even binder to binder. So this is another slide of the same for alpha set, functionally modified silicate, and carbon dioxide phenolic. So this is same model. It is interesting, Mr. Govind, for 5 minutes. You can see after coating in 24 hours, again it has been applied coating and cooled, and it has been tested again at 5, 10 and 15 minutes only for hot strength. Then you can see the strength has come down serially. In case of organic binders, from the very beginning, from 5 minutes itself, there is a drop. This is in case of alpha set and carbon dioxide phenolic. These are of course not 100% organic, these are inorganic organic binders, because partial it is inorganic. And FMS, it is 99%, 95% inorganic. So you can see the difference. In case of so-called binder, this inorganic binders, from 5 minutes itself strength drop has started, whereas in case of silicate ester, there is a drop, initial drop, because of the bond softening and removal of moisture, then it started picking up. So far it is okay. But this return strength model, which I used is for what is used in sodium silicate system at 800 degrees centigrade, you place the samples in furnace and keep in the furnace for 1 hour, switch off the furnace, next day, after 12 hours, bring out the samples and test for compression. You will see in case of your alpha set, the sample does not survive, that means it perishes, which is the property of a organic binder. In case of your 95% silicate, that functionally modified silicate self-set, it not only the sample retains its shape, but strength is quite good. But more startling revelation is that the carbon dioxide cured phenolic, its strength is more than even your inorganic binder, that is functionally modified silicate, which it's unusual. That means carbon dioxide cured silicate during your mold closing, up to your mold closing or dry strength, it is similar to organic binders, but after that pouring and post-pouring, it behaves like an inorganic binder. So this is a system of very interesting. Then again, this is another between carbon dioxide cured amine cured cold box, that carbon dioxide cured phenolic and gas cured silicate. So this is functionally modified silicate, what I was talking about. This has got tremendous potential to replace many self sets, particularly furan and alpha set, and with it is possible to reclaim also. I have seen this system is used in Italy with reclamation and reclaimability as high as 95%, and addition level it works at 1.8%. So this is a future system for self-set in many foundries and with pollution level 0. So I can show you few coarse molds and casting before wash application, after wash application, then castings as such casting, then your short blasting, and after decoring. These are the systems which are much I talked about. These are absolutely environment friendly systems. Last one is modified silicate gassing version. Middle one is carbon dioxide cured silicate and phenolic, and third one is functionally modified silicate, for which I am advocating. So you can see the castings, the steel castings have been poured, and you can see the short blasted casting. It is as good as resin bonded your casting made with resin bonded sand. These are the cores prepared with carbon dioxide cured phenolic, and this is the casting. You can see the casting is absolutely okay. This particular foundry was using your acid cured phenolic, but we have introduced the system in that particular foundry, and with this system they are getting avoiding the slow your core setting problem in winter and summer or all these things, and casting is absolutely okay. These are the two cores used in automobile foundry made with carbon dioxide cured phenolic at addition level of 2.5%. This I have already showed. There are a comparison between functional and modified silicate gassing and self-set version. Although both are silicates, but the self-set version works at very, very low working addition level, as low as 2.0%, means it is economic, it is very much environment friendly, and decoding is easy. So it can, again I am advocating for the system, it can be a system for the future with proper modifications. So this is the conclusions. Foundry industries in India major contributor to GDP in manufacturing sector. So we find its potentially to grow with availability of talents and your equipment manufacturers. This industry will grow. There are years to come. Chemical pollution from vapors and gases of organic systems released at different stages at different temperature are major sources of chemical pollution. These chemical pollutions are not visible, invisible. So it may not be having immediate effect, but it has got definitely effect on long exposure. So it is being a matter of health. We cannot compromise with it. We have to look for much and much safer systems at any cost. Maybe price will be more, your cost will be more, but you have to do that. So for what we are working for health of us and our family. Then publication from various studies show that effect of short and long-term exposure from various gases and vapors of the organic binder systems are harmful to human organs to varying extent. Then transition from hazardous organic systems to safer systems is inevitable and just matter of time. Modification of existing binder systems with how modification is possible, I could not finish all the slides. Suppose in phenol formaldehyde resin, phenol is a hazardous element, and we never talk about percentage phenol in leftover in the binder. In European countries, there is a regulation. Above this phenol, you have to put a level of human skull. So we cannot expose the foundrymen at risk without knowing them, without informing them. It is our responsibility. And I think when people ask about the gas content, when people foundrymen ask about the potassium content in alpha shade, you have got a right to ask T-phenol content of your resin. And for that, this foundry should come forward. We are ready to pay price for that, because remove your T-phenol at the last stage, it costs money. But we are ready to pay that, and we have to do that.
Thank you, Mr. Ghosh. Sorry to interrupt. You see, all the conclusions are already telling me what I wanted to say. But one thing is very clear. The inorganic binders are going to come. It may take some time because development, every manufacturer of resins and suppliers will be coming out in inorganic binders, and then how good they are, what are the problems, and will have to be looked at by each foundry. And then make a transition. As you rightly said, the transition has to be made. There is no choice. And pollution controls are coming more and more strictly nowadays regarding, see, one particular foundry in Bangalore was asked to shift from an industrial area itself only because of smell. How do you check the smell? There is nothing, pollution control norms doesn't say anything about smell. You talk about SO2, N2 and all that. But today that foundry was asked to be closed, and they went to High Court. Even the High Court finally agreed with the Pollution Control Board, and the foundry had to close. Therefore, the question will come regarding smell, and not the health effect of the gas, but the smell itself is not acceptable. And unfortunately, what is happening is, around the industrial area, the residential areas are coming in. And then it is coming closer to the residential area. This particular example of Bangalore industrial area was, the smell was noticed not in the foundry. The smell was noticed 1 kilometer away on a flat. And that fellow went and complained to Pollution Control Board, and the foundry had to close, and they had to shift out. Therefore, please understand that the impact of these pollution controls are going to become more and more stricter, and then maybe this is inevitable, as Mr. Ghosh said, it is inevitable that we have to change inorganic binders. And unfortunately, lack of time, I'm skipping the question and answer session. Please, if you've got any questions, please talk to him privately afterwards. And I will be thanking Ghosh for this, presenting this paper today, and I would like to give you a memento for this. Thank you very much.
Thank you, Mr. Govind. Thank you, fellow foundrymen.
Now I would like to invite Mr. Panda to make his paper presentation. Mr. Chandan Panda is Vice President, Technical Service and Business Development of Gargi Hutchinson, Alberta's Mumbai. And his topic is high performance cold box systems to optimizing quality, economy, and pollution. And I invite him to make the presentation. Thank you.
Good afternoon, my dear foundrymen, and thank you, Mr. Govind, for your kind introduction. Today, I am going to present about the high-performance cold box system to optimizing quality, economics, and pollution. And so, in these topics, I'll cover the current market scenario, the challenges, and the general requirement for foundry industry, the organic binder system used in Indian foundry, and the modern cold box system profile. The cold box system road to success, the development of the cold box system, and also the case studies, the cost saving through the product technology, the benefits with new innovation, and environmental behavior with reduction of organic content, reduction of monomer content, and reduction of formaldehyde. So the current business scenario and challenges, the environmentally compatible production and increased complexity the foundries are facing today. And today's topics also, lot of discussion. Our earlier author discussed about the pollution, lot of emission in the foundry industry. So the new generation cold box system that manage the balancing act by fewer emission and uncompromising performance. The organic binder system, above all, the cold box remain the dominating process for cold production, especially in the serial casting, due to its broad range of application, its effectiveness, and day-to-day the technological advancement. The modern cold box system to fulfill many requirements for serial foundries, the crucial properties is high productivity. So to achieve high productivity, so model cold box system should be the high strength level and high reactivity, long bench life, low sticking to gives the higher production, and low gas evolution in the foundry, and also low pollutant emission and high thermal stability. So the general requirement of foundry industry is the growing complexity to increase coreosity. If the casting is complex, so you have to use number of cores. So number of core means your binder addition level will increase, the effective surface area is increased, so you have to reduce the gas. The reduction of the casting weight. So the casting walls are gradually become thinner. So now the engine blocks, the casting wall thickness is 3 mm with dimensional accuracy 0.5 mm. The environmental legislation in national and international level, especially in Europe, the formaldehyde emission level is 20 mg per meter cube. So in future, so it will be 5 mg per meter cube. So in India also, so in future it will come, so we have to be ready for that. And definitely the protection of employees' health and safety. So the engine blocks. So it is that engine blocks, so very thin, it is 1.8 L to 2 liters TFSI engine. The power 85 kilowatt to 220 kilowatt. So if you see the wall thickness 3 mm with dimensional 0.5 mm and casting weight approx 43 kg. So the alloy is GJL 250, GJL 270 and GJV 450. So if we want to produce such type of thin casting, so we have to use the different arrangements. So we have to use the core package technology with the vertical pouring method. So this is the core package application.
I request you to go for the subject, directly.
So it is related to.
I know that, but what's this timing, therefore.
Yeah, I'll cover within 20 minutes. Sorry. So this is the core package application. So if we see if we want to produce such types of typical casting, so you have to use the number of cores. So thin wall engine blocks with integrated functionalities to reduce the CO2 emission. So this is the future generation for the motor vehicles. So here, especially for this core, we are using the advanced binder system to reduce the binder level and also it improves the gas content also. So and also the thin coating layer. The coating layer should be very thin. And also inorganic sand additives. If it is prone to vanning, we have to use the anti-vanning compounds. So the casting defects normally we observe in the especially in cold box. So this is the vanning and scab. So mainly it is the expansion defects. As say sand change from alpha to beta. So we got the expansion defects. The blowhole, pinhole. So this is the related to the gas. And also erosion, metal penetration. So this is the related the cold box related defects. So I already discussed the vanning and scabbing defects in the cold box. So I'll not cover this one. Already discussed that organic binder, it is the heat curing type and no bake type. So I'll cover that PUCB system, polyurethane cold box system. So this is the gas curing type cold box. So modern cold box system profile, the high strength level to reduce the binder addition level. High productivity, so it low sticking and high reactivity. So low gas evolution, so that reduce the gas related defects in the foundry. And low emission, this is the pollutant, smell and fumes. And special properties is required the elasticity and the good decoring property, so the breakdown and the bench life, higher bench life is required. So this is the general, the resin is the phenol formaldehyde ring and the solvent and additives. And activator, it is the polyisocyanide, NCO. So curing in presence of the amine, so it gives the polyurethane bond. So this is the name is the polyurethane cold box system. So we have done the FESEM. So we find that this is the bond, the binder, that between the sand, such types of bond is formed when we use the cold box system. So what is the special in the cold box? If we say the introduction of cold box system in foundry industry in 1968. So then steady growth is there, so replacing the old core making process. In 1980, but that time we are using only the thinner base coating. But in 1980, the cold box become the water-based, water resistant. So foundry are able to use the water-based coating. But in 1990, the modification of solvents done, so the plant-based solvent is used. So it gives the low sticking, so and low gas is required, amine is required, so it increases the productivity. But introduction of silicatic system in cold box binder system, it start in 2020. In 2000. So this is the first step to the partial inorganic cold box system in the history. So then lot of development is going on for cold box system. So if we go the aromatic cold box system, so in India, so the most of the cold box system is the aromatic cold box system. Then, as I say, the aliphatic cold box system, so the solvent is mainly the rapeseed methyl ester. So this is the plant-based solvent, so which is used both resin part A and part B. Then the silicatic cold box system came, so it is mainly the solvent tetramethyl silicate. So silicate, so this is the 4 branches, so this is called the tetramethyl silicate. So the cold box is now partial inorganic. So if we see this one, so aromatic. So aromatic, it contains carbon. So with aliphatic, we reduce the carbon level 5%. And with silicatic system, we introduction of 5.7% silicatic, so the carbon content reduced 16%. And with the latest development is if we increase more inorganic system, that is 12.4, and reduce the carbon content 23%. So ultimately, with reduction of the carbon content, we can reduce the CO2 emission in the foundry. So almost in India also, lot of foundry, they have started monitoring the CO2 emission every month. So this is the future. We have to use the modern binder system to reduce such types of the emission level. So the hybrid system. So the hybrid system, this is the combination of resin and activator with different solvent base. So it is easy way how the foundry can start the silicatic system. So the easy way to start to get to know the silicatic binder system. And performance of the hybrid system can really be good if we consider the productivity and the environmental aspect. So the better performance when the sand base is very difficult. So the typical example is, so in hybrid system, if we use resin aliphatic and activator silicatic, and also we can do resin silicatic and activator aromatic, and simultaneously resin aliphatic and the activator aromatic. So different combination is possible. So that's why I use the hybrid system. So we have done the case study, one of the Gujarat-based foundry, reputed foundry, and so the AFS of the sand is 56. So major sand is lying the 52, 72, and 100. So almost more than 80% sand lying in the 3 ships. So this is the retention curve, and this is the cumulative retention curve. So the LOI of the sand is 2.9% and pH is 7.46. So earlier this foundry using the aromatic system. The resin addition level is 0.8. So with introduction of hybrid system, we keep the addition level 0.65. So overall we have reduced more than 20% resin addition level, means part 1 and part 2. So we got that 0 hours, it is 110 and 105 psi that strength. So after reduction of 20% strength also, so almost 1 hour, 4 hours and 24 hour strength is almost near, and it is our specs, within our specs. So even in case of the scratch hardness, we are getting similar result. So what is the advantage of this system? So the low viscosity of resin, it gives the better mixing property of the sand. And low aromatic solvent, because hybrid system we are using the plant-based solvent or silicatic solvents, so reduce the volatile VOC compound compared to the normal aromatic system. So no smell due to the special solvent, and low sticking. So especially the plant-based solvent or silicatic solvent, it gives the low sticking tendency. So it improves the your productivity in the foundry. So very high initial strength. So it is almost 20. If we keep the same addition level, we'll get 20 to 30% higher strength compared to the aromatic system with same addition level. So the application benefits is the reduced core breakage due to the higher initial strength. As initial strength is higher, so it reduces the core breakage. High strength helps to reduce the addition level of resin and activator, so that it is almost above 20% for both part 1 and part 2. So reduce part 2 consumption helps to reduce the nitrogen in the system. So if it is 20%, so straight away you can reduce the nitrogen 20%. And especially in the green sand foundry, so that coal box sand, we are mixing with the green sand. So indirectly you helps to improve the green sand property. So in green sand also it reduce the nitrogen content 20%. So lower part 1 and part 2 addition helps to improve the sand flowability. So if the resin is less, so it improves the flowability of the sand. So flowability of sand means it gives the better compaction and to improve the scratch hardness. So higher initial strength is suitable for the robotic and water jacket application. So now we are able, one of the foundry based in MP. So they have replaced cell core in the LPDC with silicatic system. 100% they are using coal box system. So which is not possible earlier, only one foundry they are using. So the excellent moisture resistance to give the good baking properties. So when used in the water-based coating, so that your core storage properties also increase. So the less cleaning of vents, so it increase the productivity. So due to high initial strength, as we know, some critical casting, we are bound to use the anti-veining compounds. So with anti-veining compounds, it is finer. So ultimately, you have to increase your binder level. But in that case, we already get 20 to 30% higher addition level, so that we can keep the same resin addition level and we can use anti-veining compound. So a lot of discussion, Mr. Santosh Kumar also discussed about the gas related and also the pollution. Mr. Ghosh also discussed about the lot of emission in the foundry. So where that emission is, especially in the mixing, it starts from the mixing. In mixing, we get solvent and phenol. So in core production, it is amine and solvent. So in core drying, it is formaldehyde solvent, and amine. In casting, it is benzene, phenol, solvent, and formaldehyde. In cooling zone, so benzene, phenol, solvent, and formaldehyde. Even in the checkout, it is benzene, phenol, solvent, and formaldehyde. So in the total cycle, lot of emission happened. So ultimately, with reduction of the organic binder addition, we can improve. So reduction of the monomeric, especially the free phenol and free formalin. So we can do that, and reduction of the formaldehyde addition, especially in the drying. So the possibilities of the foundry chemistry to reduce the formaldehyde addition, the cold box binder system is available with active agent to trap the formaldehyde. So similarly, the coating is also available, so which can trap the free formalin in the system. So the additives also available, especially which are using different types of additives. So with active agent to trap the formaldehyde. So last word, the foundry industry has a long tradition and history. So the melting and pouring metal has shaped the world over many centuries. So metal casting was and is a very crucial, very important in the social, cultural development of the world. So the thin walled engine blocks with integrated functionalities to reduce the CO2 emission, the future generation of the motor vehicles. So high dimensional stability is required with wall thickness 0.5 mm. The number of core increase as already discussed, so it increased the gas. So the cold box system with lower monomer and reduced formaldehyde emission. So the new generation cold box system that manage the balancing act by fewer emission and also the uncompromising performance. So this is the future of the cold box system. Yeah, thank you very much.
Thank you. Due to paucity of time, again, I'll be speaking the question session. Any questions are there, please contact him directly and have a reply. But I would like to say one thing in conclusion. The systems, they are all evolving over a period of time. As the chart himself he put what happened in 1960s to 2000. The changes are going on occurring. And as the pollution control limitations and other things are coming in year after year after year, the new materials will be brought out by the manufacturers. Only thing is, it will have problems. It is not that it will not have problems. Even in a foundry which was using alpha set, but they went for the complete mechanized Nobex systems, they had to switch over to the Furanic system. Like that, there will be problems. Each foundry will face something when they try to new things, but collaborating with the manufacturer of the resins and the foundry, the via media, they have to discuss and finalize, and then they have to take it forward to see that the pollutions are reduced so that it doesn't affect the productivity of the particular foundry. Therefore, these evolutions are going to come. Only thing is you have to be, I'm very happy that they are making this presentation to make the people aware that these new things are coming up. And then the onus is on the foundries to request them to take the samples and then see what are the problems and then give the feedback to the manufacturer so that the development can become faster in our country. I thank Mr. Panda for his presentation, and I'm making a presentation on behalf of IAF for the memento for him for his participation. Thank you very much. There was a delay of our session, and then the next session also is a little delayed because we had to start a little bit late, and people are checking out from their hotels. The audience came a little late, therefore we started late. But I thank the IAF for giving me an opportunity to chair this session and very interesting papers. And thank you once again.
Thank you, Mr. Govind. On behalf of IAF, it's a pleasure for us to present you a memento.